Late one night in 1996, just as I had dozed off in bed, my phone rang. The caller was Matthias Krings, a graduate student in my laboratory at the Zoological Institute of the University of Munich. All he said was, "It's not human." "I'm coming," I mumbled, threw on some clothes, and drove across town to the lab. Years of mostly disappointing results had taught me to keep my expectation low. In all probability, whatever we had extracted was bacterial or human DNA that had infiltrated the bones sometime in the 140 years since it had been unearthed. But on the phone, Matthias had sounded excited. Could he have retrieved genetic material from a Neanderthal? It seemed too much to hope for. It's now been 30 years since Svante Pääbo and his team got that first glimpse of Neanderthal DNA, and 170 years since we first stumbled upon the fossils from the Neander Valley in Germany that gave them their name, the same fossils that would yield those initial DNA fragments. But even after all this time, we're still trying to figure out exactly what to make of them. The classic, simple explanation is that they were a distinct ancient human species, the closest known relatives of us Homo sapiens, and that they went extinct some 30,000 to 40,000 years ago. But maybe their branch of the family tree was close enough to ours that they weren't ever a true distinct species to begin with. Some even argue that, distinct species or not, they never actually died out. And in fact, from one angle, there's actually never been more Neanderthal on Earth than there is right now. To understand who the Neanderthals were and how their time on our planet ended, we need to start with what we know of their beginnings. The current thinking is that our two lineages diverged from a common ancestor at least 500,000 years ago. And after this split, we embarked on independent evolutionary journeys, theirs mostly in Eurasia, ours mostly in Africa, in relative isolation from one another. Until sometime around 200,000 years ago or more, when some evidence of waves of Homo sapiens venturing out of Africa starts to appear, with more concrete evidence pointing to an eventual reconnection with our long-lost Neanderthal cousins in Eurasia around 100,000 years ago. But still, hundreds of thousands of years of independent evolution is no small separation. A mixture of adaptation and chance meant that we evolved a host of different traits in our different environments over that time. These are often pretty obvious just from fossils. The skeletons of Neanderthals are shorter and stockier, with wider rib cages, longer, less rounded skulls with prominent brow ridges, and larger nasal cavities. Many of these are probably adaptations to their lifestyle, which often included hunting big Ice Age mammals in harsh, cold environments across Eurasia. Evidence suggests Neanderthals medicated themselves and possibly others using natural painkillers, antibiotics, and even performed dentistry. So if Neanderthals could find the healthcare they needed tens of thousands of years ago in the depths of the Ice Age, why does it often feel so annoying and overwhelming for us to find it today? Enter today's sponsor, ZocDoc. ZocDoc is a free website where you can search, compare, and instantly book high-quality in-network doctors. They have more than 150,000 providers with 200 plus specialties across all 50 states. And their website has tons of reviews from real patients and detailed doctor profiles to help you choose the right one. Plus, appointments happen fast, usually within 24 to 72 hours, or even on the same day. Your health matters, and ZocDoc makes the process of booking the right appointment at the right time with the right doctor so much easier. So if there's something bothering you that you've been putting off dealing with because the process feels overwhelming, head to ZocDoc.com/bizarrebeasts to get started and check that appointment off your to-do list. In contrast, our more slender build emerged for a different suite of challenges, like chasing down prey over long distances in much warmer environments in Africa. And these clear physical differences meant that many scientists didn't hesitate to view them as a distinct species, Homo neanderthalensis. And for a long time, they were also viewed as a lesser, more brutish, and primitive species that we replaced by being smarter and generally superior and more evolved. More recently, we've been able to peer into their genomes, beginning in 1996 with that first sequencing of Neanderthal DNA that we started the episode with. Suddenly, we didn't just know their skeletons in detail, we knew their genes too. And the single biggest revelation was just how intimately familiar with Neanderthal biology we used to be, if you catch my drift. Because as we analyzed more and more of their DNA over time and compared it to our own, by 2010, it became clear that we had a history of interbreeding with one another. In fact, people of non-African descent have up to a couple % of their whole genome that they inherited from the tryst their ancestors had with Neanderthals. And newer studies have even found trace amounts in living African populations too. Genes can spread through the overall gene pool pretty effectively as populations migrate and mix over time, meaning that now it seems like basically every human population on Earth probably has at least some small trace of Neanderthal DNA. But herein lies a problem. If we could interbreed successfully and produce fertile offspring, which we clearly could and did, then how could we be different species? And in what sense can they really be seen as extinct? See, while species boundaries can often be pretty blurry, the most common approach we use to separate them is called the biological species concept. It says that two groups are only distinct species if there is a reproductive barrier between them, meaning that they are too biologically different to produce fertile offspring. Homo sapiens and Neanderthals may have been in the process of speciation, and successful interbreeding might have even become less easy, but clearly there wasn't a full reproductive barrier yet. Hundreds of thousands of years of divergence sounds like a lot, but evolutionarily speaking, for big, long-lived mammals, it's only just approaching the kind of timescale that you need for reproductive isolation to become established. So, there's an argument that we were more like different populations of the same species, just with some regional variation. If we were looking at this same data for another animal, would we be so quick to separate them at the species level in the absence of a reproductive barrier? Is the separation we've made actually based on ego? Well, many scientists do still argue that the scale of the physical differences is enough to view them as a different species, and that the issue is mainly with trying to apply hard and fast rules like the biological species concept to situations that are far more nuanced. Because it's only one of many species concepts that can be used to separate groups, and each has their own pros and cons. The biological species concept isn't great when you're studying extinct groups whose reproductive boundaries can't actually be tested today to determine how complete the barriers are. Plus, in the genomic age that we live in now, it has become clear that interbreeding between groups that have long been considered distinct species is rampant in the real world. So instead, in certain situations, other species concepts are more useful. Like the morphological species concept, for example, which separates species if they have sets of distinct physical traits that mean they can be consistently distinguished from one another. By this approach, Neanderthals and Homo sapiens are indeed different species. So, okay, species boundaries can be fuzzy sometimes. It's something we've explored many times before. But in the case of the Neanderthals, this also makes their extinction pretty fuzzy too. On the one hand, it's pretty clear that their distinctive fossils just stopped showing up around 40,000 years ago or so. The last of these come from cave sites in Russia, Croatia, France, Belgium, and the Iberian Peninsula. And they all date to roughly around the same time, making them all possible candidates for being endling populations. After this, the Neanderthal fossil record just stops. Their big brow ridges, wide rib cages, robust limbs, and elongated skulls are seemingly gone forever. But, on the other hand, their genetic record continues. In fact, in 2015, researchers studying a fossil Homo sapiens jawbone from a Romanian cave found the ghostly trace of what could have been one of the last Neanderthals. When they sequenced the jawbone's ancient DNA, they found that this individual had a Neanderthal ancestor just 4 to 6 generations back, less than 200 years before they lived. Seeing as the jawbone dates between 37,000 and 42,000 years ago, if we take the lower or midpoint of this window, then it's possible that this person's Neanderthal ancestor may count as one of the last known individuals that we have evidence of. And it raises the ironic possibility that the Neanderthal endling was a person who had kids, the exact opposite of what you'd normally expect an endling to do. And it also means that while we have a pretty clear paleontological extinction for Neanderthals, the abrupt end of their fossil record, we don't have a clear genetic extinction for them at all. Because if they had direct descendants that live on to this day, as the DNA evidence now shows, isn't that the exact opposite of being extinct? You successfully reproduced. Congrats, you did it. And you have a ton of living offspring. Billions of them, actually. In fact, in 2025, a team of scientists published a mathematical model questioning the narrative of this being a true extinction at all, adding a new methodological approach to an old debate. Their modeling suggested that, instead of dying out, they might have simply been absorbed. See, the fossil and genetic evidence suggests that Neanderthals never really had very large population sizes, and ancient Homo sapiens were much more numerous in the late Pleistocene when we reconnected in Eurasia. So, under a scenario in which waves of Homo sapiens encountered them, hybridized with them, and did this over and over again, it would only take between 10,000 to 30,000 years before they became entirely diluted. Which is consistent with the general timeline of their disappearance and the increasing Homo sapiens presence on the continent. Now, other more dramatic factors may have played a role at times too, but the modeling shows that they aren't necessarily needed to explain the Neanderthals' apparent disappearance 30 to 40,000 years ago. Gradual genetic absorption might have been enough to seal their fate. And maybe it's better to look at them as basically merged with us. Sure, they're not around as separate entities anymore, but they didn't really die out either. They have an ongoing evolutionary legacy. We're living it right now. Like we said, that's billions of descendants today. Kind of impressive for a so-called extinct species. And it raises a pretty mind-bending twist to the story of the Neanderthals. A small amount of Neanderthal DNA in billions of people today is, by total sequence length, probably greater than the sum total of Neanderthal DNA on Earth in their heyday. Especially because, as we said, their population sizes were chronically small. Which means that, as some scientists have pointed out, there is technically more Neanderthal around right now than at any time in the planet's history. They're both extinct and, in a sense, the most successful that they've ever been. So whether Neanderthals are truly extinct or live on in us, or were never actually a different species to begin with, all depends on how you look at it. But at some point around 30,000 to 40,000 years ago, there must have been one last remaining Neanderthal. And it's often tempting to imagine that Neanderthal endling, whoever they were, as a tragic figure, someone who spent their final moments huddled in a cave, cold, hungry, scared, and alone. But their DNA also hints at another much more wholesome possibility for their eventual extinction. Maybe the very last Neanderthal spent their final days surrounded by a community of loved ones, happy and at peace, watching their hybrid children playing in the snow.